Welcome to the video on Lewis structures. This video is going to introduce how to draw Lewis structures, and I'm also going to follow up with a video of sort of a formula that you can use if you so desire. And hopefully between those two, as well as a lab video I've also made, this should be hopefully start to click. So we've looked at what Lewis structures are, and now we want to learn to draw them. So if we look at just a formula for a compound, so let's just do something simple. So methane, CH4. Okay, that formula tells me the number and the identity of the atoms in the compound. We have a carbon and we have 4 hydrogens. However, it doesn't tell me how they're connected, and that's what a Lewis structure does. It shows us how the atoms are bonded and represents the bonding and non-bonding valence electrons. So keyword here is we're looking at valence electrons. So one of our first general rule is to draw only valence electrons for molecules. Okay, every main group element, those are the only ones we're going to be looking at, except for hydrogen, want an octet of electrons, which means they want to have 8 electrons around them. And hydrogen always wants to have 2 electrons. Okay. Then you're going to place and try to arrange the atoms next to each other that you think would be bonded together. Okay. So if I have hydrogen in my formula, you won't always have that. Okay, hydrogen only wants to have one bond. Okay, therefore it's going to be on the periphery of the molecule. And another little tip is carbon always wants to be central. Okay, so it wants to be in the central atom. Okay, and so if we have hydrogens or halogens, okay, I'm going to refresh your memory here in a second of how we know how many bonds that these make, but both of these only want to make one bond. Okay, therefore they can't be in between. So if we put bonds here, okay, we can't arrange it this way, because look at this hydrogen. It would have 2 and 4 electrons around it, and we know that it can only have 2 electrons. Okay, so hydrogens are always going to be in the periphery around a central atom. Okay, this is just a reminder of the common bonding patterns. Okay, it was mentioned in the previous video. Hydrogen always wants to make one bond, carbon 4, nitrogen 3 with a lone pair, oxygen 2 with 2 lone pairs, and halogens 1 with 3 lone pairs. And this is because this is how they will fill their octet. So if you need to print this and have it with you as sort of a little cheat sheet, then by all means do, because this can really help. Okay, so we're going to look at this formula here, CH5N. So right away I'm thinking, okay, I have carbon. I know it wants to form 4 bonds. It likes to be central. Okay, I have 5 hydrogens, and I know that those want to be on the periphery. And then I have a nitrogen. Okay, and so I know it forms 3 bonds and has a lone pair. Okay, and so I'm going to start thinking about how would I arrange this. Okay, so I would place carbon here in central, and I would put 3 of my hydrogens around, okay, because it generally forms 4 bonds. Okay, then have 5 hydrogens, so I can only put 3 because I know that nitrogen needs to be, okay, it's not going to be on the periphery because it likes to form 3 bonds. Therefore, it's going to be bonded to carbon and then the 2 other hydrogens. So this here always has to match what you're given there. Okay, this would not work. So if I look at this and if I bonded everything together, okay, there's really two things wrong about this. So carbon's only making 3 bonds, so that's a definite no. And then nitrogen is making 4 bonds. Okay, and we know nitrogen wants to make 3 and also have a lone pair. Okay, and so if we finish this out here, okay, that's what the Lewis structure would look like. Okay, I kind of jumped ahead because now you're going to look at your formula and you try to arrange it the best that you can based on your common bonding patterns. And then you need to add up your valence electrons. So your structure that you draw should be the total number of valence electrons. Okay, so we have another formula here. We have 1 carbon, so 1 carbon times 4 valence electrons. Carbon's in group 4, so it has 4 valence electrons. Here we have 3 hydrogens, and hydrogen's in group 1, so it has 1 valence electron, so that gives us 3. And then we have 1 chlorine, it's in group 7, has 7 valence, so we add up 4, 3, and 7, we get 14 total valence electrons. Okay, so you can do this first if you want to, it doesn't really matter which order, okay, but you want to think about your bonding patterns and then add up your, or vice versa, add up your total valence electrons because your structure should match this number. So in the end, you should have 14 in this molecule. Okay. Then you arrange the electrons around the atoms and you place bonds between your atoms. Okay. And for your main group elements, you need 8 electrons around each of those, and for hydrogen you only need 2 electrons around. Okay, and any remaining electrons you fill the octets with lone pairs. Okay, and so that's a lot of words there, so let's go back here and finish this one out. So we have CH3Cl. Okay. And we came up with 14, let me check and make sure here, 14, yes, valence electrons. Okay, and now it's telling us to place 1 bond, 2 electrons, remember there's 2 electrons in every bond, between the atoms. So we try to arrange them, and we know how many valence electrons we're supposed to have. And now we make bonds between those atoms. And remember, hydrogen can only make 1 bond, only 2 electrons. Okay, it's going to be represented around a hydrogen. And then, if you have any remaining electrons, then you place those around the atom that needs to fill its octet. So you have to fill all the octets with lone pairs if need be. All right, so we had 14 valence electrons. I know that carbon has to make 4 bonds, so I only have 4 other atoms, 3 hydrogens and 1 chlorine. Okay, so this would be my most likely arrangement. And then I place bonds between those. So I put 1, 2, 3, 4 bonds. Okay, before I add those, if I count here, hydrogen has 2 electrons around it, 2, 2, so it's full, it's happy. If I look at carbon, I have 2, 4, 6, 8 around, and I made 4 bonds, so carbon always wants to make 4 bonds. But if I look at chlorine right now, it only has 2 electrons around it. Okay, therefore, I need to fill its octet with lone pairs. Okay, so 2 electrons on hydrogen. Now I have 8 on chlorine. Carbon has 8 as well. And so if I add all of my electrons up, 2, 4, 6, 8, 10, 12, 14, then my Lewis structure matches the calculated number of valence electrons for the structure. So all of our valence electrons have been used. Okay. If you're drawing a Lewis structure and you get to this point and you have an atom or atoms that still do not have an octet, okay, so if you get to this point and you use your number of valence electrons and you have an atom that's not satisfied, okay, then you need to proceed to this following step. So this is sort of like step 4 of what we have been going through. If this happens, this means that you need to make multiple bonds, okay, to fill the octets. All right, this one is satisfied the way it is. We have single bonds around it, so there's no need to do anything else. But if you hit this point and you cannot make your structure satisfied with octets, then you're probably going to need to draw in double bonds or triple bonds, and these are called multiple bonds. Okay, a double bond is here. Okay, it contains 2 electrons in each bond. So a double bond has 2, 4 electrons. So each one has 2 in it. A triple bond has 6 electrons. So 2, 4, 6. So there's 6 electrons in a triple bond. I don't know why it keeps doing that. And here we have 4 in this double bond. Okay, so when you're drawing and going through these steps and you hit a point where your atoms' octets are not full, then one of the lone pairs that you've drawn can be converted to a bonding pair, to a double or even sometimes a triple bond. So let's look at an example to help you. So C2H4. Okay, the first thing we do is we arrange the atoms. Okay, it doesn't really matter which order you do 1 and 2, but we think about, okay, we have 2 carbons. We know those like to be in the middle. Okay, so we're going to have to connect those 2 together, and then the hydrogens want to be on the periphery. So there's 4 hydrogens. So that looks good. Okay, and then we add up our valence electrons. Okay, so we have 2 carbons in group 4, so that's 8. And then we have 4 hydrogens in group 1, so that's 4. So we have 12 electrons total. That's what we have to represent in our molecule. So if we do what we did before, and we add bonds and lone pairs, so we do this. Okay, so there's a bond. We connect all of our atoms there. Okay, so if I add this up, I've got 2, 4, 6, 8, 10. I already have 10 electrons. Okay, and remember 12 is the number we're going for. Okay, so if I look at this, this cannot be correct because, okay, this carbon, 2, 4, 6, 8, okay, but it also looks funny because carbon always wants to make 4 bonds. It doesn't typically have a lone pair. And then if you look over here, this carbon only has 3 bonds and only has 6 valence electrons. Okay, so even though we've met our 12, so if you count 2, 4, 6, 8, 10, 12, okay, this structure is still not correct. Okay, and so this is where we need to form a multiple bond. So what we do is we convert that lone pair to a double bond. All of our valence were used, but we still have an atom that does not have an octet. Therefore, we change one of our lone pairs into a bonding pair between the carbons, forming a double bond. Now, if we go around, we have 2, 4, 6, 8, 10, 12. We have 12 valence electrons represented. And carbon has 2, 4, 6, 8. And this carbon has 2, 4, 6, 8. Now they're sharing 4 electrons in a double bond. All right, thank you, and I'll see you next time.